Hello viewers, tutorial 13 question 8, and we have a couple of simultaneous equations problems to solve. So the first one, which is the pair of equations 3x plus 2y equals 7 and 5x plus 8y equals 21. So both equations have an x and have the y on one side of the equation, which means it looks like it's ready to go for elimination. There are a couple of ways that we can do elimination here. The first is that we could multiply that first equation through by 4, which would give you an 8y in both equations, and then we could subtract them from each other. Or we could do our usual method of elimination, so second equation times 2 and the first equation times 8. That would work, and that's what we'll do. Okay, so we've got the first equation times 8, which is going to be 8 times 3x is 24x, plus 8 times 2y is 16y equals 8 times 7 is 56. And the second equation we're multiplying by 2, so that's going to be 5x times 2 is 10x, plus 8y times 2 is 16y, equals 21 times 2 is 42. Now we want to cancel out these 16y terms, so the two signs of the y terms are the same. That means we'll subtract them. 24x minus 10x is 14x. 16y minus 16y is 0. And then we've got 56 minus 42, which is 14. So there's our equation that only involves x, and we can divide through by 14 to get x equals 1. And let's sub into one of the original equations. Let's call that one equation 1 and equation 2. Let's substitute into equation 1. So we've got 3x, which is 3 times 1, which is 3, plus 2y equals 7, so therefore 2y equals 4, and that means that y must be 2. So your solution is xy is x was 1, y was 2. Let's check that that fits the second equation, 5x plus 8y equals 21. Well, x is 1, so that's 5x is 5 times 1, which is 5. 8y is 8 times 2, which is 16. 5 plus 16 is 21. Okay, perfect. Now problem B, let's turn our attention to that right hand piece of paper. So we've got y equals 2x plus 3 and 12x plus y squared equals 37. Note the y squared, that forces us to use substitution. So we need to substitute the first equation, which already has y as the subject, so we don't need to do any rearrangement. Into the second equation we get 12x plus y, which is 2x plus 3, and that's squared, equals 37. So we'll need to multiply out this bracket. We have 12x plus 2x plus 3 times 2x plus 3 equals 37. So 12x plus, multiply out these brackets, 2x times 2x is 4x squared, plus 2x times 3 is 6x, plus 3 times 2x gives us 6x plus 9 equals 37. So that's a quadratic equation. We will solve that. So we'll simplify first. So we've got 4x squared. How many x do we have? 12 plus 6 is 24. Then we've got plus 9. We're moving the 37 to this side, so that will be minus 28 equals 0. And this has a common factor of 4, because 4, 24 and 28 are all on the 4 times table. So we can divide out 4. So this will be x squared plus 6x minus 7 equals 0. So we need to factorise that equation. So it factorises into two brackets. we're looking for numbers that add to 6 but multiply to negative 7, which are positive 7 and negative 1. Okay, so we've got two solutions. We've got x equals, if x plus 7 is 0, x equals negative 7, and if x minus 1 equals 0, then x equals 1. So when x equals negative 7, y is going to be 2 times x plus 3, which is 2 times negative 7 plus 3. 2 times negative 7 is negative 14 plus 3 equals negative 11. Let's check that that satisfies the second equation. 12x is going to be 12 times negative 7, which is negative 84. Y squared is negative 11. Square that, we get 121. So 12x is negative 84 plus 121, which is 37. Check. Okay, so when x equals 1, y equals 12 times 2 times 1 plus 3, which is going to be 5. And let's check that that satisfies equation 2. 12x is 12 times 1, which is 12. Y squared is 5 squared is 25. 12 plus 25 is 37. So our two solutions are x and y. First solution we got was negative 7, negative 11. And the second one was 1, 5. Okay, thanks for watching. Over and out.